God dagen. Vi hørte fyrir et prat vi bar Niklasen, granskare av Sedsunon, vi Sjóvarfallsorku. Og I det får vi så, det vujer vi tog, og for å snakke vi Martin Edlund, som stjóri I fyritøkuna Minesto, som tan fyritøkan og ser samarbeid vi gjør Sjóvarfallsorku I Vestmannasundinum. Vi får høre hva fyritøkan og gjør, og hva det har valgt førjar, og hva teirra Sjóvarfallsorku skipan kan bjóa imot til ganske Sjóvarfallsorku skipan. Ja, velkommen Martin, og takk for at du kunne gjøre det stund til at gjøre et innsløg sammen med oss.
Thank you very much, thank you.
Jeg får begynne å spørre hva endamålet vi fyritøkene, og hva initiativet oppnå?
Yeah, we're building, designing and developing a new type of tidal power plant that is based on a system that flies kites underwater. So what we do is that we basically push a turbine through the water with this system. Some people have tried this historically and also now in air with what is called high altitude wind systems. But we are unique in doing this for moving water in the oceans. And it's also a well-protected technology in water for Minesto with patents.
Okay, ja. Hvor det avverst at gagnuta Sjóvarfallsorku som en orskukjelda?
Well, one obvious reason is because the energy is there. It's in all oceans surrounding all continental coastlines. The kinetic energy in water is an attractive and compact form of kinetic energy. So I think it's 800 times heavier than air, for instance. So it's a nice, it's nicely, neatly packaged in that sense. The other reason linked to it that makes it attractive is that it's completely predictable. So you know exactly when you will produce. So for the Faroe Islands, for instance, if you use tidal energy in the north, in the middle, in the south, you will always have some electricity because there's a phase shift, and you know that for 10,000 years ahead. So that makes it attractive in that sense. And for ocean currents that are continuous, it becomes even more attractive, such as the Gulf Stream, which can be harvested energy from in certain parts of the world.
Ja, okay. Som vi skiljer rett, så det en av firmånen vi Sjóvarfallsorkene at vekkrir ikke lukka avgjørende som vi øronværende orskukjelton, for nær man kan framleia strøm.
That's correct. And I mean, then there are, with our systems, there's another obvious advantage that, I mean, if you have a dependence on tourism and attractive nature, such as the beautiful Faroe Islands, it's obviously so that avoiding massive build-out of wind towers as an alternative is then sort of less attractive from having something that is invincible under the surface, which is just an extra to it, of course, but of value in some areas, and I presume particularly for the Faroe Islands.
Ja, okay. Hvordan det da det kommer til Sjóvarfallsorku? Det sånne særlige omstøver i Jessica Aldante og avbjøringer kanskje vi Sjóvarfallsorkene?
It's definitely a challenge to find the best areas in the world to start harvesting this source of energy. And the earlier we are on the evolution of the technology, the more important it becomes to be in the really sort of perfect spots first. Because with our technology, as with all new technologies, we have cost learning curves to climb to make it fully competitive. And I'd say that's also one of the reasons why the Faroe Islands is so attractive for us, because the sheltered areas in the fjords, like in Vestmannasundinum fjord, where we go, makes it easy accessible to the systems with low wave heights. So when you need to service and maintain, you can do that cost effectively. It's also very close to shore. So the grid connections that are already there from SEB's perspective, they're easily accessible compared to many other areas of the world. So that's definitely important, but it also takes some competence and investments to identify and analyze those sites. And I would say that it's perhaps one step more complicated than finding the right spots for wind farms, for instance, which we are pretty good at now in the world in many places. And then the challenge related to the cost structure initially is something to work with and overcome.
Og hver hotren så verja framleia elorske ur sjóvarfallsorku søvliane annars?
The most, let's say, natural or the easiest way of considering this is, of course, to say, okay, we have horizontal axis turbines for moving air. Let's try that in water as well. And I even think there are solutions of trying to extract tidal energy from ancient times using horizontal axis turbines. So there have been many projects, and there are still many companies around the world, Europe, US, Asia, that are working with horizontal axis systems. So that's the most obvious principle to use. But there are challenges with that where you need, it seems like you depend on very high flow rates, which means that where we are, for instance, in Vestmanna, most horizontal axis technologies would not be suitable there because they would like higher tidal flows. And I think that goes for most of the tidal flows in the Faroe Islands and in most other places of the world as well. That there's a lot of flow, but not on the very high peak levels, above, let's say, 2.5-3 meters per second when the flow is at its strongest. And you get that rarely in the world, which means that those horizontal axis systems, they will in general be more niche-oriented technologies. But with our kite flying principle, we can harvest larger areas of flow and make it a more useful technology and simply make use of this natural resource to a larger extent.
Ja, hatt akkurat det at jeg spyrje om hvordan fraviker tikkara skipan seg fra den verande eller kjent og hatt noen at gagnuta sjóvarfallsorku og det.
Yeah, and it's this wing that is collecting the energy. So it's a wing tethered to the seabed. And when the flow hits the wing, we can then steer the wing in a trajectory. So we move it in a shape of an 8, which means then that this will fly in the same way as when you, as a child, as a hobby, are flying a kite with 4 strings. Then you can steer it in a trajectory, move it around and fly it pretty fast. And this is what we're doing with our underwater kites or underwater, maybe similar to an airplane that is moving there. And the turbine is is attached to this wing and then rotates with a generator and generates as a moving system.
Ja, hvordan stor så heser drekan
A 1 megawatt kite is maybe a 14-meter wingspan system. So you can say it's pretty large, but compared to a lot of other energy systems, it's really a compact, lightweight thing, which is the core to our advantage. And we think that we can build even larger systems. So we talk about multi-megawatt single power plants, and that will be rather impressive machines, wings, they're flying in the ocean currents. And you can certainly consider wingspans of 20 meters and above for the future. But the systems we put in Vestmanna, the 2 first, they are 100 kilowatt each, and they have a wingspan of around 5 meters. So that's smaller, lightweight systems.
Nu du nevner at drekan feras rundt og komme opp I skjolta fer enn hvis man har en stationera Sjóvarfallsorkuskipan. Hvordan kjøtt ferast disse drekene så?
They fly significantly faster than the actual flow of the tidal current. So when you have a tidal current of let's say 1.5 meters per second in the water, you get around 6 to 8 times that speed for the kite itself, which then will be the speed that the turbine on board experience. And that's sort of the key to this invention, that the turbine experience a very high throughput flow. So with that 1.5 meters per second flow in the ocean, the turbine will experience a 10 meter per second flow through it. And the speed of the flow has a huge impact on how much energy you get out. It's even a cubic relationship. You can imagine how important it is to get it to fly quickly.
Så jeg kan umynda meg vi er som kreften og ferien og snakker om at her krever en ordens fest i havbottenen også vekna. Hvordan ser vi tog?
Yes, which is part of, as we see it, a part of the system. So together with suppliers, we develop gravity-based foundations for those types of, let's say, single installations. So we are now installing those gravity-based concrete and steel foundations as a first part of the subsea infrastructure to be put in place.
Søvliane hava slukar sjóvarfallsskipaner kraftigare än ekvi luikahalt. Tui at du hever saltvattna gera og man arbeider en skipan som i sjånon og tui atkomman kanskje helt så løtt. Fraviker tikkare skipan på nægra mata fra hesson traditionella matan at servisera og luikahalta.
This is one of the areas where we've been working the hardest to really accept that an immature technology will need a lot of caretaking in the early days. So our system is designed to be towed out to site and then to be detached from the gravity-based foundation, which means then that we can tow it back to Vestmanna and do service on shore. So that's a very important aspect to it. That takes some innovation and that takes some work to get those systems to work cost effectively. But we are doing very well now in that area and are confident that the systems will be significantly less expensive to launch and recover. So that's a key part of the functionality of the systems, which also means then that the divers or large DP vessels will not be needed for the ongoing operation phase of electricity production and associated service then.
Om man hikker av heimasynene til dikken, så ser man at tid hava just slukka skipan standarden i heimen. Hvordan hava hesar bor seg?
Yes, we've been testing for many years with 3-meter wings in Northern Ireland in a place called Strangford Lough. So we've learned over the years how to calibrate the control system and try to optimize trajectories and how the system behaves when it turns when the tide shift direction. So those tests have been very valuable over the years to really fine-tune the technology. And we've also flown model scale systems now this spring that are, let's say, the same design as what we're putting in Vestmanna. And that has been really interesting and important and good successful trials for us. And we have also in North Wales, where we have our operations team in a place called Holyhead, actually a steep coastline, not very far in it the way it looks like as Vestmanna and the coastlines on the Faroes. But there we have flown a 500 kilowatt system in 2 test campaigns, the summer 2018 and 2019. So we've actually been dealing with even larger systems than the design that we're putting in Vestmanna now. But what we're putting in the Faroe Islands is the latest evolution of optimized hydrodynamics and a commercial design of the system. So this will be our most important trials in the history of the company.
Ja, nu kommer en siste tekniske spurninger. Hvordan håndterer tikkere skipan sjóvarfallsskifte?
The system is buoyant, so it floats a little bit in the water. So what happens is then that when the flow is too low for the system to keep flying, or when it no longer makes sense to fly because it generates so little electricity, it goes into a parking mode, still stabilized by the low flow. But when the flow then lose speed completely, the system will float towards the foundation and stand right above the foundation for a few minutes. The tide turns and then it will start flowing in the other direction downstream. And when it reaches a certain cut-in speed, it commands itself to do the start procedure, where it moves and dives in a certain direction to pick up speed and move into this trajectory phase. And this is a stable, very well managed procedure that is autonomous and something managed by the control system in the kite.
Ja, så har vi några sista spurningar om verkætlana spesifikt i Vestmanna. Hvor har dit valgt førjar og hva særligt her?
I think there are a few reasons for it. One reason is the natural resource. With the Faroe Islands being positioned in the Atlantic, where there is a strong general movement from tides moving the Atlantic Ocean back and forth, and all the islands then create the narrow straits in between them, creates very good quality tidal resource. So it's the physics of the natural resource is very important. It's also the right water depth. But you can find that in many places. Then I think the other side of it is then the political will to move towards renewable energy, not just talk about it, but actually execute and do it, which is happening in the Faroes. That's very, very important. And in this, the role of SEV as a partner and customer in this is absolutely key for us. They have a better understanding than we have of the economic value of balancing the grid mix with different complementary sources of energy to create one of the world's, or perhaps the world's first 100% renewable energy system. So this predictability of tides is something that even if the technology is somewhat more expensive to the start, it will be compensated by the fact that you don't have to have overcapacity. So you can compensate by having a lot of wind energy resource, but then you will have to compensate for days when the wind is just blowing a few meters per second. But with the tides, you know exactly the capacity you need, and you can balance your grid mix. And SEV is leading in the world, actually, I'd say, to understand this hands-on, given that the Faroe Islands is a very manageable scale and scope of working with the grid mix. So I think that's important in this sense.
Det är ju som heter öppnas inte för möjligheten att Sjóvarfallsorka kan virka som en sån stöv över baseload som man kallar det, eller att köra konstant, framlägga konstant en ström.
Yes.
Ja, okej. Det är ju inte som att verkætlan i Vestmanna hever en topp här som hon framlägger nekvan stream och så eisen här som inte blir framlagt i sjóvarfallsskifti är det några måter man kan bryta på detta och göra det mer stövot?
No, you will have for one specific site you will have sort of a sinus shaped production curve where it will peak when the flow peaks and then it will go down to zero. But the good thing is that if you look at the different fjords and the phase shift in when the flow peaks, that's very interesting to look into the Faroe Islands. If you compare Skåpuna with Vestmannasundinum and the fjords to the south, you will see that there will be differences when it peak. So the kites in one fjord will not turn at the same time as the kites in another fjord. So if you do this in a clever way, you can reduce the need for overcapacity, and you can definitely reduce the need for energy storage, which of course is a cost burden to any energy system.
Okej, så om jag skilter rätt så är det möjligt att göra flera liknande verkætlan som i Vestmanna, ganska norranfjörs och vid Sorøyden eller mitten stora döm om Ærastane, så är det du fast en mera jauna elframlägslo.
That's the vision. That's what we're seeking, and that's what makes it so attractive.
Ja, men tack för samrøvna. Detta var ekvilja avverst att höra och vanande eller vi gleder och kunna ölja att söka skiparna i bruk.
Yes, me too. I'm actually hoping I can get an opportunity despite the COVID situation to come back to the Faroes now already this summer to take part in the exciting commissioning work.
Ja, allt läge. Tack för det.
Thank you very much. Bye bye.